Hey guys, good morning. So, in chapter 8 till now we have studied the definition of motion. So, we understand motion quite well. We have studied scalar and vector quantities, distance, displacement, speed, velocity, right? So, these are the things which we studied till now. Okay. So, from today onward, we are going to cover something new. So, the first topic which I am going to talk about is uniform motion versus non-uniform. Okay, uniform motion is uniform motion. So let us try to understand what is uniform motion, what we mean by uniform. So see, uniform is purely an English word, so it means something which is constant. So as the name suggests, uniform motion means an object is traveling at a constant speed over a period of time, right? This object traveled with a speed of say 5 meter per second for a duration of how much, 20 seconds, you can say 20 seconds. Yeah, so during this time, the speed is constant. I'm talking just about speed, I'm not talking about velocity. I repeat, I'm just talking about the speed. The speed is constant for 20 seconds. So this type of motion, you can say it is a uniform motion, right? So I have written down something here for you. I think you should be able to see here. In uniform motion, yeah, speed is constant, velocity may or may not be. Yeah, it is true. Suppose you are driving a car. You're driving a car and you drove for say 5 hours. Okay, 5 hours at a speed of 12 kilometer per hour. Okay, and the time duration for which you drove your car is 5 hours. I'm saying you just drove your car. Let us say straight line motion along a straight line. Okay, so what can you say? Is the motion uniform motion or non-uniform motion? It appears that by definition it is uniform motion. Okay, you can say it is a uniform motion. Okay, no problem. For now you can say it is uniform motion. But this, see, this per unit time should be very small, as possible, I would say, as small as possible. So in this particular example, we should preferably take speed uh, with per unit time in terms of second. What I mean to say that, let us convert this speed in into meter per second. We know there is a factor, that is 5 by 18. So you just multiply with 5 by 18 and you will get speed in meter per second. Okay, so this is 2, this is 3, you are going to get 3.33 meter per second. Let us analyze the motion of this car for just for 1 hour. Let us analyze just for 1 hour. Okay, so in 1 hour, what is 1 hour? 1 hour equal to, if you convert it into second, so it will come out to be 3600 seconds. And how much is the distance you have covered? Sorry, you have covered a distance of 12 kilometer, that is 12,000 meter. So we are going to analyze this, that the car traveled a distance of 12,000 meter for a duration of 3600 seconds. So there are high chances that the driver might have driven the car at a speed of 3.33 meter per second, right? For, let us say, for how much? For d1 equal to 200 seconds. And he might have gone more than or less than 3.33 meter per second for rest of the duration. This is possible or not? This is generally the case. Okay, this is for rest of the duration. So now you tell me, is the motion of the car uniform? What do you think? Sometimes it is 3.33 meter per second speed, and rest of the time it is more than or less than 3.33 meter per second. So now can you say it is a uniform motion? Absolutely not. So that's why I'm telling you that this per unit time should be very small, as small as possible. So we should go for second instead of hour. Okay, so this is what I have written for you. So you can write this in your exam. So when an object travels equal distance, okay, per unit time, we can say the object in uniform motion. The per unit time should be very small, preferably second instead of hour. So it is for precise judgment. Precise judgment, yeah, this is the key word. It is for the precise judgment, guys, between non-uniform and uniform motion. Overall, the speed must need to be constant. Again, the velocity may or may not be constant, because velocity is a vector quantity. It has direction associated with magnitude. While driving a car, there are very high chances that you change the direction of the car. Sometimes you can take left turn, right turn, you can go straight. So anyway, direction keeps on changing, so velocity will change. The distance traveled per unit time is directly proportional to the time, right? So when the speed is not constant, it is called non-uniform motion. It is as simple as that. So we are done with uniform motion and non-uniform motion. So going forward, this concept will be used thoroughly. So have a good grasp on this particular concept. The next concept is average speed. Okay, so let us take an example. So there is an object, okay, which starts from, say, point A, okay, and it reached point B. Fine, guys. It traveled with a speed of 5 meter per second for first 2 seconds, 2s. Fine, and then it traveled at a speed of how much, 8 meter per second for the time duration of 3 seconds, and finally it traveled at a speed of 12 meter per second for a time duration of 5 seconds. Okay, this is the case. I repeat, an object starts from A. It moved for 2 seconds at a speed of 5 meter per second. For next 3 seconds, it moved at a speed of 8 meter per second, and for next 5 seconds at a speed of 12 meter per second. Suppose if someone asks you, what is the speed of the object during this journey? So what would you say? The object traveled this 5 meter per second for first 2 seconds, 8 meter per second for next 3 seconds, and 12 meter per second for next 5 seconds. So does it sounds good? I think the person is asking about a single value. He's asking about a single value of speed. So in this case, average speed is the answer. Okay. So basically there are 3 speeds which is given. So let us call it V1, V2, and this is V3. We know what is the formula of speed. Speed is S by T, distance traveled by time. We know speed, the value of speed. We have speed, we have time, so we can calculate S. So the formula of S will be V into T. Fine. This is the equation we can use in order to calculate the constituent distances. So the first piece of distance which the particle moved is S1. Let us denote it by S1. Okay, so what will be its value? It will be V1 into what, t1. So let us put values. So it will come out to be 10 meter. What is the value of s2? Similarly, same formula. It will be 8 into 3. How much, guys? 24 meter. S3, how much? It is 12 into 5. Okay, so in total, how much distance object has covered? It is s1 plus s2 plus s3. So what will value? 60 plus 10, 70. 70 plus 24, 94 meter. Yeah. What is the total duration if I ask you to calculate? T equal to t1 plus t2 plus t3. 2 second, 3 second, 5 second. It will come out to be 10 seconds. So now the question is how to calculate average speed. So there is a formula for that. Formula says average speed is total distance covered, that is s, and total time spent, that is t. What is total distance? 24 meter, and total time. So this the average speed will come out to be 9.4 meter per second. So the answer of the question is 9.4 meter per second. So you can say the object traveled at an average speed of 9.4 meter per second. So this is what I have written down for you. So when the motion of an object is non-uniform in nature, so please pay attention. It is non-uniform in nature, right? This is the keyword, non-uniform. See, the object is traveling at varying speed. Initially it was 5 meter per second, then 8 meter per second, and then 12 meter per second. When the motion of an object is non-uniform, so it is purely non-uniform motion, agree, in nature. And suppose we want to know the speed, then average speed is the answer. Fine. So how to calculate average speed? Total distance traveled by total time taken. It is just a speed, so the SI unit is same as that of speed, that is meter per second. Fine. The next concept which we are going to talk about is average velocity. Okay, guys. So for this, let us analyze motion of an object along a straight line. Motion of an object along a straight line. This is point A. Suppose an object is here. Okay. It traveled to B. Okay, with a velocity of 5 meter per second, and it moved this much distance for time, say t1 is equal to 2 seconds. Okay, and after that it moved from B to C for a duration of, say it is 4 seconds, and the velocity here is 6 meter per second. Fine. It reached at point C. After reaching point C, it started traveling in the reverse direction. Okay, so now it goes in this direction. It started in this direction and now it start going in this direction. Okay, so it started from C and reached another point, so it is D. Okay, and it traveled with a velocity of, say, 8 meter per second, and the entire duration, say it is t3 is equal to 5 seconds. So let me explain you again what I mean to say here. An object started the journey from point A. It traveled with a velocity of 5 meter per second for the duration of 2 seconds. Okay, it reached point B, and from B it traveled with a velocity of 6 meter per second for the duration of 4 seconds. It reached point C, and now after reaching point C, it reversed its motion. It started moving in opposite direction. Okay, and from here it started covering the rest of the distance with a velocity of 8 meter per second, and it traveled for t3 equal to 5 seconds. So in this case, if someone asks you with what velocity the object moved, so what would you say? That for first 2 seconds the object moved with 5 meter per second. For next 4 seconds the object moved with 6 meter per second, and then 8 meter per second. Does it sound good? I think it not. Actually, the person is asking for the single value of velocity. So in this, if that is the case, so average velocity comes into picture. So now let us try to find out how to find out average velocity. We clearly see that object travels with varying velocity. Okay. So v1 is, so before we start, let us adopt a sign convention. Right side of x-axis is plus and left side is minus. Okay. What is the value of v1? v1 is 5 meter per second. Fine. t1 is 2 second. Value of v2 is in this direction, so it is plus 6 second, sorry, plus 6 meter per second. Okay, and t2 is how much? 4 second. And then what is the value of velocity? Plus or minus? Tell me. Left side of x-axis we have taken negative, so it will be minus 8 meter per second. Fine, guys. And the duration is t3 equal to 5 second. Fine. So the formula of average velocity is total displacement. Okay, let us denote it by d, by total time. Okay, total displacement by total time spent. So let us calculate d first. So in order to calculate d, we we must need to calculate the constituent displacements. So let us calculate d1. So d1 is, what is d1? So d1 is v1 into t1. So what is v1? Sorry, this, what is v1? v1 is plus 5 meter per second into 2, so it will come out to be plus 10 meter. Fine. What is d2? So in the same way we will go, d2 will come out to be 6 into how much? 4. So it will come out to be plus 24 meter. And what is d3? Just pay attention here. d3 is minus 8 meter per second. Okay, minus 8 into how much? Duration is 5 second. So it will be minus 8 meter. See, so displacement is coming to be minus 40 meter. Calculate the net displacement or the total displacement, whatever you say. Hence net displacement is what? The sum of all this, means d1 plus d2 plus d3. Okay, this is what it will be. And if you start adding 10 plus 24 plus, it is minus 40 meter. So it will come out to be how much, guys? It will come out to be minus 6 meter. See, minus 6 meter. So minus 6 meter is the net displacement during this journey. So minus 6 meter is the difference between the initial position and the final position. Okay, so you can say this is net displacement, net d. Okay, so now we can find out what is the value of t. T is sum of t1, t2, t3. So it will come out to be 2 plus 4 plus 5. So it will come out to be 11 second. Now we can calculate average velocity. So average velocity will be d by t. Okay, what is the value of d? Minus 6 meter. What is the value of t? 11 second. So what is the average velocity? It is minus 6 by 11 meter per second. So you can say the object traveled with an average velocity of minus 6 by 11 meter per second. Minus, what is the meaning of minus here? That means the net displacement of the object is in the negative direction from A to D, right? So that is all about uh, average velocity with concepts. So for you, I have written down something. You can write this particular example. Write this definition. What is average velocity? When an object moves with non-uniform velocity. Pay attention, guys. Non-uniform velocities, right? And we want to know single value of velocity with which the object traveled. Then average velocity comes into picture. Fine. The formula for average velocity is total displacement or net displacement by total time taken, and you can suffice this particular example and you are done with average velocity. Yeah guys, the next topic is acceleration. We are going to cover that. So before we start, so can you tell me what do you know about velocity? So velocity is a vector quantity. We have learned that, right? It has magnitude, okay, it has direction both, and the SI unit is meter per second. So basically velocity is a speed, but direction is also associated with it. So if I, so how do we denote velocity? Velocity with a vector mark, this arrowhead. This is velocity. So suppose the velocity is say minus 5 meter per second, and I am considering the same sign convention, plus and minus. Okay, so minus 5 meter per second. You understand that the object is moving leftward. So what is the magnitude of the velocity if I ask you to calculate? It is very simple. Put this two sticks. Magnitude will always be positive. So what I mean to say that magnitude of velocity is nothing but speed. Secondly, let us revise one thing. We have learned that what all factors can affect the velocity of an object. Velocity has magnitude and direction, okay? So we can bring a change in velocity due to in three ways actually, by introducing a change in magnitude, direction, and both. This is what is written. Magnitude, direction, both. We have already studied that. So now I'm going to take an example where the magnitude of velocity is changing. Magnitude of velocity is changing. That means the motion of the object is non-uniform. Can we say that? I think we can say very easily. Velocity of the object is changing. It is not constant. Let me write for you. Velocity is not constant. If velocity is not constant, you can certainly say it is non-uniform motion. Suppose an object travels from A to B with varying velocity. Say at the start of the journey it has a velocity of u. It reached at point B and the final velocity is v. You are seeing a gradient in the velocity. Gradient, I mean there is a change, right? So this change in velocity might have this change in velocity must have occurred over a certain period of time, right? So let us say this change occurred in a time duration of delta t. We can say that. Agree? I repeat, the object started from A, it reached to B, initial speed is u, final speed is v, time spent is delta t. So we are clearly seeing that there is a gradient in velocity. So that is delta v is there. So what we are seeing that there is delta v, right, over a period of time, that is delta t. So this delta v by delta t is nothing but this is called acceleration. Fine. So if I ask you to calculate acceleration, you can calculate it. So we generally denote acceleration by a letter. Okay, so we can say final delta v by delta t. Fine. Final velocity minus initial velocity. Time duration you can denote it by t also. So this is what I have written for you. So during non-uniform motion, so it is very important when acceleration comes into picture, guys. The precondition is that motion of the object must be non-uniform. Means object should be moving with varying velocity. Only then you would have gradient. So during non-uniform motion of an object, the velocity keeps on changing at every point of time. The rate of change of velocity with respect to time is called acceleration. Mathematically it is what? Delta v by delta t, v minus u by t. Right? It is a vector quantity. Why? Because velocity itself is a vector quantity. SI unit, you don't have to remember this. We know what is the SI unit of velocity. It is meter per second. We know the SI unit of time as, so it will come out to be meter per second square. So SI unit of acceleration is meter per second square. Right? So now I'm going to ask a very simple question to you. So just try to give answer. During uniform motion, okay, during uniform motion, this word along a straight line, okay, what can you say about acceleration? Can you say something? Uniform. The object is in uniform motion along a straight line. That means an object is moving along a straight line. Yeah, it is written. It is given the question. So what can you say about acceleration? The answer is acceleration is 0. No acceleration. Why? Because there is no gradient of velocity, no change in velocity. It is as simple as that. Okay, guys. So there are two types of accelerated motion. This is very simple thing. The types of accelerated motion I have covered: uniformly accelerated and non-uniformly accelerated. So if I ask you to give uniformly accelerated, as the name suggests, object is moving with uniform acceleration. It is as simple as that. Example is freely falling body. Suppose you are holding this pen here and you just release it. Just release it. It will go down, okay, under the influence of force of gravity. It has a fixed value, that is 9.8 meter per second. So basically this is acceleration. We denote it by the letter of G, acceleration due to force of gravity. So you can give example of freely falling body for uniformly accelerated motion. And can you give an example of non-uniformly accelerated motion? I think you should. Suppose you are driving a car and you are passing through a crowded space where lots of people are standing. So I think you are forced to drive your car with great variation in velocity. Sometimes you might have to stop, sometimes you drive, sometimes you take right, left, this kind of things. So it will be an example of non-uniformly accelerated motion. Okay.